Okay, so just another reminder that this coming Thursday, what's happening at GCC? Advising Day, so make an appointment to meet with your advisor on Thursday if you can. There are no day or evening classes for Thursday, but if you can't come in Thursday, then go check out your advisor's door. They probably have a schedule of open appointments. So meet with your advisor at some point. The main idea here is the earlier you register, the better the chance you have of getting a schedule that's a good fit for you. Okay, so there's that, and then also note that Open Classroom Week is happening right now. It has started today. So take a look at the GCC homepage. You'll find a list of all the classes being offered. Come up with a schedule if you're interested in seeing different classes or different teachers to help you plan for what you're going to take next fall. In terms of our class, this is day 2 out of 3 on inverse trig. Our last quiz is the one that we're finishing up here. And notice that between here and the next test, we have no more quizzes, we have no more projects, we have nothing between us and the test, okay? So nothing is going to distract us. Test is coming up on April the 2nd. Let's see what this week looks like. We have 1 day on inverse trig, a 2nd day on inverse trig. Friday is our review for the test. Monday is the test, okay? 1 week from today. And again, in terms of the test, just want to remind you about the YouTube stuff that we've got, just so you know what's available to you. There in the packet, you'll find another whole bunch of sample test problems, and if you know what you're looking for, it's easy to find. So for example, if you type in 108 sample test 2, problem 3, and you hit enter, it will find B. So as long as you know the format, it's easy to find exactly what you're looking for. It also pulled up the whole playlist for the entire sample test number 2. If you don't type that in, but rather you type in my YouTube name, GCC Math Winoker, you'll also find my channel. And inside of my channel, you can find all the videos that I've made. You can see a whole slew of them down here. But inside of the channel, if you go to videos, and then up here to playlists, you will see 108 sample test 2. And inside of there is me going through all the practice problems. And you can also check out the numbers on the right. You can see some folks have already started looking at these in preparation for the test. Okay? Any questions on how to get here? Okay. Yes. That's right. Yeah, everything from the last test. Another way to say that is everything in the packet that you guys are holding right now. That's the whole idea with the packets, is that they separate the tests. Any other questions before we dive in? Okay, then let's go ahead and try this one here. Again, we're going to kind of work off the packet for a bunch of today. A little bit of this will be in the packet, but first thing I want us to do is to try, this is just a reminder, we did a problem like this. We might have done exactly this one last time. Looking to solve using the unit circle, no calculator. Sine of theta equals negative root 2 over 2 for all the thetas between 0 and 360 degrees. So can you guys write that one down, refer to your unit circle and to your neighbors, and see if you can come up with the solutions to that equation. Okay, so looking at the unit circle here, I want the sine to equal some number. Is the sine the x or the y? Sine is the y, so we're looking for y values of negative root 2 over 2. You can see there are 2 of them, one in the 3rd quadrant, one in the 4th. Just to remind you, this agrees with that all students take calculus thing we had talked about. Down there in the 3rd and 4th quadrant, only tangent is positive, only cosine is positive, which means sine is what in both cases? Negative, right? That's telling you what's positive. To have a sine be negative, of course, we're going to get answers in the 3rd and 4th quadrants. So we're looking for the angles that correspond to what I circled. Looks like 225 and 315. Is that right? Any questions on that? Okay, and this is really, really common when you're solving a trig equation between 0 and 360. Almost all the time, you'll end up with exactly 2 answers, right? There's a symmetry happening here. So there'll be 2 answers to almost every equation. All right, let's come down here to the next question. We're going to find, using the unit circle again, the inverse sign of negative root 2 over 2. So can you guys check with your unit circle and check with your neighbors? See if you can figure out the inverse sign of negative root 2 over 2. Okay, so let's come on back together. There is a subtle but important difference between the problem that you guys solved first, solving that equation, sine theta is negative root 2 over 2, and what I'm asking you for down here, inverse sign of negative root 2 over 2. Feels like it's the same thing, because ultimately what we're going to do is take the inverse sign of both sides. The inverse sign goes on the right-hand side, and you just get theta. So it seems like we should just get 225 or 315, or maybe both. Okay, we're not going to get both, because the inverse sign is defined to be a function. So you give it one number, it will spit out one angle. So it has to make a choice, 225 or 315. Which one's it going to pick? It's not going to pick either of those. And in order to figure out which one it's going to pick, you need to be aware of the domain and more importantly, the range issues for these three trig functions. Mathematicians have made some choices here. You just need to know the choices. Skip the domain for a second. Just look at this red thing here, inverse sign of x. I'm looking for the inverse sign of negative root 2 over 2. According to this thing here in red, the range of the inverse sign is all the angles between negative 90 and 90. If I ask you for the inverse sign of something, you have to give me an answer that's between negative 90 and 90. You cannot say 225. You cannot say 315. Okay, between negative 90 and 90, so negative 90 is going this way. 90 is going this way, so you have to give me an angle out there in either the first or fourth quadrants. It feels like 315 suits the bill, but it doesn't, because 315 is not between negative 90 and 90. But you can write another angle that's just like 315. How much is that going the wrong way? That's negative 45 degrees. Negative 45 is the same as 315, but negative 45 has the added property that it's actually inside of the range. Okay, so this thing right here is equal to negative 45 degrees. If you type it on the calculator, it will say exactly negative 45 degrees. Inverse sine, not that one, negative root 2 over 2. What should I check before I hit enter? Check the mode. What's the right mode for inverse sine? We're doing degrees, so right now it's degrees. If I had said give me an answer in radians, the right answer would be radians. So inverse trig functions, they don't care what mode you're in, but you need to know what mode you're in. For this problem, we want a degree answer. So I hit enter and it should give me negative 45. Not 225, not 315, nothing else besides negative 45. Any questions on that? It's subtle, but we just have to be aware mathematicians have made these choices for the inverse trig functions. So you need to land in the range no matter what inverse trig function we're talking about. Okay, let's go to the next page. So the next page, we're going to do a couple of things from the packet. So if you're near page 39, you can check there. And the only reason I'm talking about this thing right here is just to give a little bit of motivation as to the choices that mathematicians have made right over here. I'm just going to kind of motivate why we pick 0 to 180. We could have picked something different. If you don't care about why we pick 0 to 180, then just like hit the snooze button for the next 90 seconds. But let's come here to number 2. We'll go to Chris. Okay, you guys remember talking about inverse functions in 107 maybe, and definitely we talked about it this semester. How can you tell looking at the graph of cosine whether or not it has an inverse? The horizontal line test. Does this graph pass the horizontal line test? No, because there's a horizontal line that hits more than once. How many times does the horizontal line hit? Infinitely many. You could not fail the horizontal line test worse than the inverse cosine or inverse sine, sorry, worse than sine, cosine, or tangent, right? Not only do you hit more than once, you hit infinitely many times. Any line that hits the graph is going to hit it infinitely many times. So what do we do? Well, we're going to restrict it. We're not going to let it hit more than once. So how about we think about this part of the cosine? We're going to curve around here. And we're going to curve around here. How many times has the blue line hit so far? Just once. We're going to curve to there. Is that thing, does that pass the horizontal line test? Just the yellow part. What if I start to draw up here? It doesn't anymore. So we need to stop. So where's a reasonable starting and stopping point? Well, seems like starting it at the top, ending it at the bottom, and don't go anywhere else. All the stuff between the top and the bottom. What angle is this one at the bottom? That's pi, 180 degrees. What angle is the one at the top? 0. Does this kind of arbitrary looking thing that we wrote down last time make any more sense now? We're always going to pick the thing between 0 and 180. That's the biggest piece of cosine where it still passes the horizontal line test. It still has an inverse. That said, you didn't need to pick those ones. For example, could I have picked this one and maybe this one? Does that green thing pass the horizontal line test? Yeah, but we don't choose that. We'd end up sounding kind of silly saying, okay, pick answers between 270 and 360, or between, I don't know what's out here, 180, is that 540 and 630, something like that. I think 0 to 180 is a much more natural thing. This yellow is a much more natural thing. There are natural things for sine and tangent. We can talk about them after class if you want to see. But again, it boils down to accepting as fact that we have defined the inverse trig functions to always give you an answer in those 3 ranges. Okay, so before we move on, we'll just put up the quiz stuff. All the quizzes are in, right? Okay. All right, so my first one, oh, there's a quiz right there. Thank you. Okay, so first one, inverse sine of a half. I got pi over 6. Is that right? Okay, and then the next one, negative pi over 4. Again, it's got to pick something in the right range. So if you put, what's out there? 7 pi over 4, it's just not in the right range. Okay, then we got a trig function that you're supposed to write for me. So let's move this over. This is not the only choice. There are infinitely many right answers to this question, but for me, a negative cosine was the natural thing to choose. There's a pi over 12 here. That's 2 pi divided by the period. There's a 25. That was the amplitude, how far stretched it was from the middle. What was the middle? Was the 55. Okay, so that's that one. But then that's assuming that we had this nice starting point here, the starting at 4. But if we actually start at midnight, then we need to shift the thing over. So I got a t minus, same as up above, but just a t minus pi over 4 in the parentheses. Is that right? Okay. Absolutely. You could do like a t plus 20 or something. I mean, there's a lot of different shifts that will land you on the right thing. Yeah. Okay, and then on the back, using unit circle maybe, I got -1 for the secant of pi. And then the next one I got a √3. That was the tan of pi over 3. And then finally, down here, so second quadrant angle, the cosine is the adjacent divided by the hypotenuse. So I labeled the -√5 and 3. And then how did I get 2 over there? Pythagorean theorem. And then once we know that, then finding the value of sine is just a matter of doing that opposite over hypotenuse thing. So I think it's 2/3. Okay, again, do we want me to do this? Because I don't need to do it. It's like a few people get good news and then more of us end up feeling worse. So I don't know if we should do this, but okay. All right, so that's that. We'll come back here. Okay, let's go down to here. All right, so we just finished that one. And again, just recognize that the quizzes are worth a small, insignificant almost compared to the tests. So It's just a little checkup. Can you do this now? If yes, wonderful. If not, you got some time, but you got to figure it out before we get to the test, because that's the thing that's worth a lot. Okay, we're going to go to advanced for 3. Oh, actually, we did that already. Let's jump to 4. Okay, so we've seen this cosine to the -1 notation. That kind of makes sense. -1 generally means inverse. I'm not going to write arc cosine very often, if at all, but I just want you to know in case you see it in the book, it means exactly the same. So if you see an ARC in the front of a trig function, it means inverse trig function. Okay? All right, can we go down here and try number 5? So take a moment to write this one down. We're going to solve this problem with no calculator. It's the cosine of 2 theta is -√2/2 for all the thetas between 0 and 360. All right, so we're going to say about 2 minutes right now in your groups. See how much you can get done. Okay. So let's come back together and we'll talk about this one. So I told a couple of groups that -√2/2, it's a common looking number because it's on the unit circle. So we were looking for cosine, which is the x, and we want it to equal -√2/2. And let's see, that happens right, let's see, different color. So -√2/2 for the x is here, and it's here. So my answers are 135 and 225. Is that okay? Those are the original answers. We're going to change stuff, but those are the angles that we're looking for: 135 and 225. So I guess what I'll say is this. Basically, that equation up there is saying cosine of some angle is equal to -√2/2. See how strong my finger is? Just move the whole board up and down like that. Right, that's what it says. It happens that the angle is no longer simply theta. It's now a little more complicated. It's a 2 theta, but it's just cosine of some angle. And I can find cosine of some angle on the calculator, or sorry, on the unit circle. Turns out that the angle on the one hand could be 135 degrees. Or, what was the other angle? 225, right? Those were the angles that you grabbed from the unit circle. But then we go back and we say, well, it wasn't just any old angle. What was it specifically? It was really 2 theta. So this is a good moment to say, okay, I can now recognize what the angle actually was called. It wasn't just theta. If it was just theta, we'd be done. It was 2 theta. So we have a tiny bit more work to do. How do we solve for theta? Divide by 2. So we get theta equals 67.5. And theta equals, what is that, 112.5? Is that good? Why do you say no?
That's weird because theta is still less than 180.
Yeah. Well, I want the answers up to 360. Yeah, definitely want both. Those ones both work. These angles are pretty small, aren't they? 67 and 112. Yeah, so we're doubling in the original equation. Yeah. So there's actually a little bit more going on here. These 2 answers are correct. Turns out there are more answers. Answers that we haven't found, which is strange. Let's go back to our unit circle again. We were looking for an x coordinate to be -√2/2, and we found 2 of them, circled in red. Okay, we accepted 135, we accepted 225, they're both correct. Suppose that we decided to wrap around and just go a little bit further. So we pass 135, and then we land on it the second time we hit it. How much is that angle? 360 plus 135. 495, right? Is 495 between 0 and 360, which is where I want my answer to be? No, which is why 495, yeah. Like normally 495 is out of the picture. We don't bother wrapping around because we just care about 0 to 360. But what are you going to do with this thing in order to find theta? Is you're going to divide it by 2. That's what we did before. And if you divide this by 2, Does it then land between 0 and 360? It does. So we need to know, and I'll tell you how, but we need to find all the answers. And so how are we supposed to know that we're supposed to go even further? I mean, I'll put it down here. This isn't generally how I would solve it, but I could write another one, or the angle is, what did we say, 495? Which looks like it's too big. But because of this idea of crossing it off and calling it 2 theta, dividing it by 2 then brings it down into the right interval. So half of that is what, 247.5?
You like to think of it as 0 and 7.
Yeah, this one is actually looking for the original numbers between 0 and 720 because of that 2 theta. There's one more we're missing. Can you guys check with your neighbors and find the last one? Okay, so what was the last really big angle before you cut it? It was 585. Normally that's way too big, but we recognize we're going to cut it in half, and that's going to shrink it down and bring it into the 0-360 interval. So what's half of that? 292.5. Right. Pass a day. Yeah, that's a really nice way to think of it. So let's look at the graph. I'm going to graph cosine of x, and we'll think about degrees, and that's fine. So I'm going to go 0 to 360. 0 to 360 will go by 90s maybe. And then -1 to 1. And then we'll take a look at our graph. Standard cosine, one single oscillation between 0 and 360. And what were we trying to make it equal? Was it negative root 2 over 2? Is that what it was? Negative root 2 over 2. So we'll hit our horizontal line. How many answers do you see? 2. In fact, 135 and 225. Remember that the hash marks there are 90s. So that's 90. First answer is at 135. Trace that right up. 180 is down at the bottom. That seems reasonable for 225. Those are the answers we find. You guys know that multiplying inside of here by 2 is a horizontal compression. It's going to give you 2 complete cycles. And so if we take a look at the graph, not of that one, but down here, we'll make cosine of 2 theta. And maybe we'll make this a little bit thicker. You're going to see it's smushed. And how many points of intersection there with that horizontal line? 4 of them. You had only 2 before, but then you brought another 2 in that weren't in there. You brought 2 more in. And so those answers are exactly what we have here in purple. It's a nice observation. Richard, can you hand her the thinker? Thank you. Questions on this? Okay. Suppose that we didn't know, like how are we supposed to recognize that we're going to get these extra answers? Because it seems like normally every time we look at the unit circle, we find 2 answers, no more, no less. So how do we know? Okay, how about we do this? You find your 2 fundamental angles, 135 and 225, and we're going to pretend we don't realize we're supposed to bring in 495. You have 135 and you have 225. But we did this last time. We said, okay, 135 is just one possible way to write the 135 angle. 135 angle. Remember sticking a plus something here at the end? Plus 360K. That's just saying wrap around as many times as you want to, and then stop at 135. And the same kind of idea here. Plus a 360K, right? That's all the answers. Okay, but then what did we do to both sides of that equation to find theta? We divided by 2. So we took the 135, we divide it by 2, we get this. But what else are we supposed to divide by 2 now? It's that 360K. Put it here in black. Plus, what do you get when you divide it by 2? 180K. Same thing in the next equation, plus 180K. I'm going to pretend that we don't see these numbers down here. We don't know anything down there. But here's what you can do. Now that you've got all the solutions you want, I'm going to move down just a little bit. So what did we say? 67.5 plus 180K. I'm going to write that down here. And what was the other one? 112? Okay, this is a list of all the solutions to the equation up above. We just wanted the ones that were between 0 and 360. So how do we find them? Well, we make a little table. We have K, and we have, I'll call it theta 1 and theta 2. Theta 1, theta 2. Two fundamental answers, no more, no less, every time. Suppose that we decide we're going to start with K equals 0. How much is the first theta if K is nothing? 67.5. How much is the second theta if K is still 0? 112.5. Those were the answers that we all found. Now what are we going to do with K? Now we're going to make K equal to 1. If you plug in K equals 1, 67.5 plus 180 is how much? How much is it? 247.5? Have we seen that number before? That's the one that 495 got cut in half and landed on this. If you plug in 1 into the bottom equation, 292.5. We've seen that one before too. Well, there's nothing stopping us from continuing. What's the next K? 2. Plug in K equals 2 into the top equation. 427.5. Is that still between 0 and 360? No, we don't want that one. But now we see why. It's just too big. What was this supposed to be? 427.5. Plug in K equals 2 in the bottom one. 472. Is that right? Too big. If I wanted to go backwards, I could plug in -1. If you plug -1 in that first equation, we'll get some minus angle, which maybe is okay in some context. We don't want it here, but we could put it. And in the second equation, is that right? That seems like it's too big. It's looking, is that right, or is that, maybe it's okay. What is it?
It would be negative.
7.5. Okay, negative version of the first one. We just want the answers between 0 and 360. We found them. They're all here. If you try to increase the K, you get numbers that are too big. If you decrease the K, you get numbers that are too small, negative. This is how we find them all. Any questions on that? Is this hard or easy? Weird. All right, let's see if we can give you guys a different one. Okay, unit circle only. Use your calculator only to do arithmetic. Don't do any inverse trig on the calculator. But can you guys solve this one? What did we just do? Was that a sine or a cosine? That was a sine, right? Oh, that was cosine? Okay, let's do a sine. Sine of theta, sine of 3 theta equals half. Looking for all the answers between 0 and 360. I'd encourage you strongly to do this business with the K. See if you can use your unit circle, write down some stuff with the K, and find all these answers. Okay, so the same idea as before. You find your fundamental angles. In this case, sine is a half. The fundamental angles are 30 and 150. There's almost always 2 fundamental angles. You just find them, ignoring however complicated this thing in the parentheses is. Doesn't matter what it looks like when you're looking at your unit circle. And you got to make sure you remember to stick on that 360K. 30 is just one of many angles that lands on that same 30-degree line. So you put your 360k. In this case, we need to divide everything by 3 in order to solve for theta. And I get 10 plus 120 and 50 plus 120. And then we just make our chart. K equals 0 will always get you your fundamental angles. In this case, well, it will get you the things that are like your fundamental angles, 10 and 50. And then plug in K equals 1. They're still pretty small, so I decided to try K equals 2. And they also snuck into the 0, 360 range. If I try K equals 3, angles will be too big, bigger than 360. If you try negative K, you'll get angles too small. Can you guys start to kind of see a pattern here? How many answers were there to this problem? There were 6, and this was a 3 inside of the parentheses. How many answers to this problem? There were 4, and that came from a 2 inside the parentheses. So what do you do with the number in the parentheses to predict how many solutions you'll get? You multiply it by 2.
But I mean, what would happen if it was like 3.3 or something? That one of your answers would have just barely studied the other one.
Yeah. So what? Yeah. So what we're saying here, I guess, is if it's a positive integer up there, then it feels like doubling it tells you the answer. Tells you how many. If it's something not as nice, you just make your table, and you might find one sneaks in and one doesn't.
So it's good for your ballpark.
Yeah. Yeah, and I think that's actually what Garrett had done before when he said, oh, really, we're looking up to 720. Yeah, here we're actually looking up to 1040 because of the 3 theta. Topher? Okay, so good question. If I ask you to solve for all theta, then that means give me the thing with the k's in it. Okay? Solve for all theta, it's 2 equations with the k's. If I ask you to find the thetas between 0 and 360, it is ultimately the 6 numbers in there. You don't have to do a table, you just have to get me 6 numbers. Okay, let's do one last one where we kind of tweak and push this a little bit further. Suppose that we had to solve this equation. Negative 0.2 equals sine of, let's do a 2 theta plus 100. And again, looking for all the answers between 0 and 360. We are going to use the calculator a little bit. Yes. So we're going to do this one together. There's enough new stuff on this one that I'd like us to do it together. First, can we use Allie's prediction thing to guess how many answers? Can you hold up number of fingers? How many answers do you expect in this equation? Yeah, a few folks are saying 4. So the plus 100, it's not really clear how that's going to affect things. I mean, it'll shift the graph left or right. I guess left. The negative 0.2, you won't find it on your unit circle. Maybe that matters, maybe no. But some folks are saying we're going to get 4 answers just looking at the 2 in front of the theta, doubling that number. Okay, so let's give this a shot. First thing we need to recognize, because negative 0.2 is not one of the nice unit circle angles, what are we going to have to do? We're going to have to do inverse sine, right? I mean, like, so let's move the inverse sine over here. Inverse sine of both sides. Inverse sine of this. Yeah, that's kind of the idea. I'm going to write this step for a while. I just want us to see all we're doing is we're putting inverse sine in front of both sides of an equation. And the whole point of that is that what is inverse sine of sine, or what happens to them, they cancel. So the right-hand side is just 2 theta plus 100. Okay, left-hand side, it's not on the unit circle, so calculator. We'll just go to the nearest degree. That's good enough for me. Inverse sine of negative 0.2. Negative 12 degrees, is that to the nearest one? I mean, like I'll give you, I will ask for more accuracy than this, but right now that decimal isn't going to do anything positive for us, so just round it to -12. What are you tempted to do as you solve for that theta? What's that? Round. Okay, so we've rounded. Subtract 100, right? I mean, we're solving for theta, so we subtract 100. But before we do that, how many fundamental answers do we always have? 2. Before you play any games with the solving this equation, you need to find the other angle. The other angle is something like -12. All right, so here's my unit circle. -12 degrees is in there. I'm looking for the other angle where the sine value is the same as the sine value at this point. Is the sine the x or the y? Sine is the y. In which quadrant? Is there another point with exactly the same y? It's over here in the third quadrant. And our job is to find what that actual angle is. And you got to use the symmetry. Calculator will never give it to you. Any ideas how to get that full angle? Yeah, it's the 180 plus the 12. Have to look at the picture. There's no way around it. So that angle is about 192. That's our other fundamental angle. This is getting us into this idea of reference angles, which is our main topic for next class. So we'll come back to more examples like that, but I think this is kind of a nice lead in for next class. So that's the one angle. I will call that theta 1. And on the other side, 2 theta 2 plus 100. What did we say? -192. You're welcome to change it. You can change that -12, which was just going the wrong way a little bit. You could really go like 348, the positive way. We could also leave it like this. We just need to find 2 really different angles, and I think we did. These are not the same angle. Topher? Radical form, where? Oh yeah, that would be like the most accurate way to write it. Yeah, that would be great. Definitely not mandatory. Before we start playing with the solving for theta, what are we missing? The plus 360s. You got to put it here. If you put it at the end, then you won't have, like, what's the last thing we're going to do to solve for theta? Is divide by 2. If you do that, and then you put in your plus 360, you're not going to have divided the 360 by 2. So you find your 2 fundamental angles, you stick this plus 360k at the end, and then finally, we're going to do the easy algebra that's involved. All the steps to this problem are typed up in the notes for next class, so we will see this all written out. But like I said, I just kind of want to lead into it a little bit. Solving for theta, 2 steps. First thing is subtract the 100. So we get theta 1 is -112 plus, and then we divide by 2 plus 180k. Did I not do that? No, I did not. All right, let me do this in 2 steps. I thought I was fancy. 2 theta is -112 plus the 360k. And then divide everything by 2. Thank you. So we get negative, what is that, 56? Plus 180k. Two theta 2. First thing again is to do what? Subtract 100. So that becomes 92 plus the 360. And then divide by the 2. So 46 plus 180k. Okay, so I know we're out of time. We still need to do what? We're going to put them in the chart. We expected 4 answers before. We're right, we're going to get 4 answers. But this is going to be kind of funky in that if you plug in k equals 0 into the bottom, how much do you get? 46, that's legitimate between 0 and 360. If you plug in k equals 0 into the first theta, negative 56, that's not in the right interval. Yeah, I mean, if you just keep adding, you will eventually find that you're going to need 3 rows, which is weird because we should only need 2 rows. So just keep plugging in, find all the k's between 0 and 360. All right, just to be clear, because the homework assignments have gotten messed up a little bit, the homework assignment is now officially assigned. This one on the bottom of page 42. This is due on Wednesday. And we'll see you guys then. Yeah, go for it. I